Welcome back, everyone. In this video, we will focus on our first topic, which is the rules of probability. Then in a separate video, we're going to go over Bayes' theorem. So let's get started. So here are the 9 rules of probability. We will be covering each one, including some examples to explain how they work. So the first probability rule is that the probability of something happening is always going to be between 0 and 1. 0 means it has no chance of happening, and 1 is a 100% chance of occurring. So probability rule number 2 states that when we add up all the probabilities of all the possible outcomes, it should equal to 1. So let's see an example of how these two probability rules work together. A sales manager has placed 3 products on display in the store. So this table shows the probabilities associated with the number of products that sell in the first 30 minutes on display. So X represents the number of items sold, and then P of X is the probability of that many items being sold. For instance, there is a 0.2 probability that 0 items will be sold in the first 30 minutes. So here is rule number 1, in that for any event of interest, our probability of it occurring will be somewhere between 0 and 1. You can see each of our probabilities in the table here are between 0 and 1. Now, according to rule number 2, if we add up all of our probabilities of all the possible outcomes, this should equal to 1. Let's review rule number 3 next. So in this rule, the probability of an event of interest is equal to the sum of the probabilities for each individual outcome forming that event of interest. So, for instance, if what we are interested in has 3 potential outcomes to occur, the probability for each one will be added up together. So let's check out an example for this rule. We have the same story as before. The sales manager has placed a new toy on display for sale at a Target store. Here is a table of probabilities for the number of products that sell in the first 30 minutes on display. So if we wanted to know what the probability that 2 or more products will sell, we would identify our related probabilities to selling 2 or more products. So here we have highlighted 2 and 3 toys being sold, since this would satisfy our event of interest. We then would add up the probability at each event to get a total probability for our event of interest. So in this case, 2 or more products will sell at 0.5 probability, or a 50% chance. So the complement rule is not considered one of the 9 rules covered in the textbook, but we'll cover it here now since this rule is the corollary to the probability rules 1 and 2. The complement rule states that the probability of the complement of an event E is simply 1 minus the probability of that event. So again, using our same Target store example, we have the probabilities shown here, and we now want to know what the probability is that 1 or more products will sell in the first 30 minutes on display. So according to our previous rule, we can simply add up the probabilities for each scenario where 1 or more products is sold. So here we have highlighted 1, 2, and 3 toys being sold. And so we'll add up the probability of X equals 1, 2, and 3. So that is 0.3 plus 0.4 plus 0.1 equals 0.8. Using the complement rule though, we could find the same answer in a faster way. So we could look at the complement of what we're interested in. So in this case, the complement of 1 or more is 0. So what we could do is then we could take 1 minus our complement probability. So in this case, the probability of 0 items being sold is 0.2. So 1 minus 0.2 equals 0.8. And we get the same answer as before. Let's review rule number 4 next. So probability rule number 4 is an addition rule for any 2 events. Here, when we talk about 2 events occurring, you'll see the word or, which means we add. So for instance, here's a Venn diagram on the left, and where the 2 areas overlap in the middle is the overlap between the 2 events. So let's consider a pack of cards example. If we took a pack of 52 cards, and we wanted to see the probability of drawing hearts or drawing kings, you will notice that there is an overlap, and that is the king of hearts. The formula states that we'll take the probability of event 1, so in this case, cards with hearts, and then we're going to add the probability for our second event, which is kings. But then we must subtract the probability of getting a king with a heart. The reason why we do this is because we don't want to double count the probability of our king of hearts appearing because there's an overlap. Let's check out another example. When drawing from a deck of 52 cards, what is the probability of drawing a red card or an ace? The or tells us that we're going to use the addition rule because we want to add up the probabilities of getting either a red card or an ace. So we know that there are 26 red cards in the deck of cards. So there's a 26 out of 52 chance that we're going to get a red card in that same deck. We also know that there are 4 aces, so we have 4 out of 52 chances of drawing an ace. Notice though that we have identified as our probabilities for red cards and aces has an overlap of red aces. So we need to subtract 2 over 52. Remember, we don't want to count the red aces twice. So we have a fraction here with the same denominator. So we'll add up the 26 and the 4 and then subtract 2 with the denominator over 52 and we get 28 over 52. So the probability of drawing a red card or an ace is 0.54. Let's review rule number 5 next. So probability rule number 5, again, this is another addition rule, but this is specifically for mutually exclusive events. So there is no overlap. So for example, here, if we have aces and kings, there is no overlap between the two events. To find the probability of pulling aces or kings, we would simply add the probability of each together. Since both events cannot occur at the same time, the probability of both occurring is 0. So let's check out a different example for this rule. Boot World has 3 styles of work boots. 6 pairs of style A, 12 pairs of style B, and 2 pairs of style C. A clerk randomly picks a pair to put on display. What is the probability that this boot will be style A or style C? So again, the or tells us that we're going to add up both probabilities. So we need to identify the probability of each boot occurring. We know that there are 6 out of 20 boots, so there is a 0.3 chance of style A. Style B has 12 pairs, so there's a 0.6 chance for this style. And then finally, style C only has 2 pairs, so there's a 0.1 chance for style C. Since if one boot style is selected, another style cannot be selected because the store clerk can only pick 1 pair. We know then that the events are mutually exclusive. So the probability of selecting style A or C would be the probability of A plus the probability of C. So we know that boot A is 0.3 chance of occurring, whereas C is a 0.1 chance of occurring. So we add up these probabilities and it gives us a 0.4 or a 40% chance of pulling either style A or style C. Let's review rule number 6 next. The conditional probability for any 2 events states that the probability of one event will occur given some other event has already happened. So this means there's a connection between the 2 events occurring. So in the numerator of the formula, we have the probability of both events occurring together. That is the joint probability. Then we divide it by the probability of our second event. That's known as the marginal probability. Let's check out an example on this one. The managers of a golf course conducted a study on the types of golf balls that golfers use based on their handicap. The lower the handicap, the better the golfer plays. We have a joint frequency table for 100 golfers surveyed. If a player has a handicap of 10 or more, what's the probability that she will use a Nike golf ball? Each row of the table represents 3 ranges for the golfer's handicap. As you can see here, the different events of interest have been labeled with an upper E and a number. So for example, E1 is the event that the golfer has a handicap of less than 2. Then in the columns are the type of golf balls or brands that each golfer used. So what if we were interested in the event of interest that a golfer has a handicap of 10 or more? That would be the last row here, or E3. At the same time, we're looking at the probability under E6 where a golfer is using a Nike golf ball. That would be this column here. Sometimes it's helpful to mark the event of interest along the rows and the columns to help organize your thinking. So our two events of interest are players with a handicap of 10 or more and that also use a Nike golf ball. We will take the probability of choosing a Nike golf ball and having a handicap of 10 or more. So we're going to put a 10 in the numerator, and then we're going to divide by the probability that the golfer has a handicap of 10 or more. We need to add up the numbers from event 3 or at the bottom row. So we're going to take 7 plus 8 plus 10 plus 23, and we get 48. So we're going to take 10 and divide by 48, and we get 0.21. So the probability that someone will choose a Nike golf ball, given that they have a handicap of 10 or more, is 21%. So let's review rule number 7 next. Probability rule number 7 is the conditional probability for independent events. So if you recall, independent events do not affect each other in any way. So the conditional probability of one event occurring, given that a second independent event has already occurred, is simply the probability of the first event. So let's go ahead and review rule number 8 next. The multiplication rule for any two events can be used whenever we want to find the probability of two events, but we do not know their joint relative frequencies. So let's check out an example on this one. So imagine we have a small boutique hotel which has 20 rooms. 5 of the rooms are suites with a living room and a bedroom. The other 15 are traditional hotel rooms, meaning they don't have living rooms. What's the probability that the first 2 rooms booked during the week of October 13th through the 19th are both suites if the bookings are assumed to be random? So we use S to represent suite and T to represent traditional room. So in this case though, we only care about the suite themselves and we want to find the probability that our 2 rooms that are booked will be suites. You can see here what we do with our formula is that we first take the probability of getting a suite twice. Since we know that there are 5 suites out of the 20 possible rooms, we take 5 and divide by 20, and that gives us the probability of our first room. Now, because we want to know about 2 rooms, we must multiply it for the second event, which is the second booking. We now must change our numbers because the first room is already booked. We must take it out of our possible outcomes. So in this case now, we have 1 suite already booked, so that leaves me with 4 suites left available to be booked. Also, since we've already booked 1 room, that leaves me with 19 rooms remaining. So my second event is 4 suites remaining out of the 19 remaining rooms available in the hotel. So when we multiply our fractions across, we get the probability that our first 2 rooms booked in October will be suites at 0.053. Let's review our last rule, rule number 9. The multiplication rule for independent events is when our events are independent, we could simply multiply them together. So let's check out an example. A Midwestern city with 3 major airlines that serve the airport, suppose 60% of passengers fly United Airlines, 30% fly Delta, and 10% fly Southwest. Further, suppose that 70% of the flyers are flying for pleasure and 30% fly for business. If the type of trip and the airline used are independent of each other, what's the probability that a flyer uses United and is a business traveler? So we'll take the probability of a United flyer and the probability of a business traveler, and we're going to multiply them together. So the probability a passenger flies United Airlines is 0.6 and flying business is 0.3. We multiply them together and we get 0.18 chance of a United traveler traveling on business. To wrap this up, let's practice some of these rules of probability together. So the URS Corporation Construction Company has submitted 2 bids, one to build a large hotel in London and one to build a commercial office in New York City. The company believes it has a 40% chance of winning the hotel bid and a 25% chance of winning the office building bid. The company also believes that winning the hotel bid is independent of winning the office building bid. So first, we want to set up the probability of winning the hotel bid. So we know that's a 40% chance, and the probability of winning the office building is a 25% chance. The probability that the company will win both contracts, which is rule number 9, the multiplication rule of independent events. So I'll take 0.4 times 0.25, which gives me a 0.1 chance of winning both bids. Let's look at what is the probability that URS will win at least one contract. So this is rule number 4, the addition rule for any two events. So in this instance, we would take the probability of winning the hotel plus the probability of winning the office building, and then we're going to subtract the probability of winning both contracts. So we take the 0.4 plus 0.25, and then we subtract the 0.1, and we get a 0.55 chance of winning at least one contract. Let's say we also want to know what's the probability that URS will lose both contracts. Since we know the probabilities of winning the contract, we can use the complement rule to know the chance of losing. So for the probability of losing the hotel, we would take 1 minus our probability of winning. So 1 minus 0.4 gives us a 0.6 chance of losing our hotel bid. So if we do the same thing for our office building, we'll take 1 minus the chance of winning, or 1 minus 0.25, and that gives us a 0.75 chance of losing the office bid. Since we want to know the probability of losing both contracts, we'll use the multiplication rule of independent events and multiply our probabilities of losing each contract. And that gives us a 0.45 or a 45% chance of losing both contracts. Well, everyone, that wraps up this first video covering our first topic on the rules of probability.